Kia ora Year 12 and Year 13. I'm going to start going through last year's calculus papers, and I'm starting with the achieved questions from integration. So I've chucked them all into one video because hopefully they'll be pretty fast. So question 1 is this one. So we have to find the integral of x over 3 plus 3 over x. So I'm going to write that first of all in this form. So 1/3 of x plus 3 over x dx. Now you don't have to do that, but if you're still working at achieved level, sometimes these fractions can give you a bit of trouble. If we want to anti-differentiate that, we're going to have 1/3 times something x squared. We have to undo the squared when we differentiate by multiplying by 1/2. The next one, 3 over x, comes from 3 times the natural log of x plus c. So cleaning that up, we get 1/6 x squared plus 3 ln x plus c. Okay, on to question 2. We've got an exponential and we've got a surd. So the first thing I'm going to do is rewrite the surd as a fractional power. I'll just fix the pen up a little bit. So we've got the integral of e to the 4x plus 4x to the power of 1/2 dx. So these are this is backwards chain rule. So the exponential function differentiates to give us the exponential function. So we're going to start with e to the 4x. When we differentiate that though, we're going to get a 4 coming out. We have to undo the 4 by timesing by 1/4. Next, we're going to have something x to the power of 3 over 2. We want to end up with 4. When we differentiate this, we'll have 3 over 2. We undo it by timesing by the reciprocal. So that's what we get. And I'm going to just clean up that line, giving us 1/4 e to the 4x plus 8/3 of x to the 3 over 2 plus c, the constant of integration. Now the next one's a little bit more interesting. We're given the value of a definite integral. So this question is testing that you understand that integration gives us the area under a curve. And we're told that the area under some curve h of x between x is 1 and x is 5 is equal to 6. I think it helps to draw a really quick sketch here. So we're not told anything else, but we're told that that area is 6. And then we're asked to find the value of the function when it's been shifted up 2 units. Now I'm going to try and draw the same function. It's probably not going to work. So there's my function shifted up 2 units. And I want the area between the same limits of 1 and 5. So you can see that what I've got is what I had to start with, which is 6, plus this rectangle here. And that's got an area of base times height, so 4 times 2, which is 8. So the value of this integral is going to be 6 plus 8, which is 14. Those questions testing your understanding of kind of the way integration works graphically have come up, I think, a little bit more often in past years. So it's just make sure that you're really confident with the area below the curve and the area above the curve and what happens when they cross over and all of that. So that was a pretty straightforward one. Okay, question 3. The best way to do this is to expand the brackets first. So in here we've got the integral of x squared plus 2x root x plus x. I'm just expanding this quadratic. I'm going to rewrite this term as a fractional power. So it's the integral of x squared plus 2x to the power of 3 over 2 plus x dx, which gives us 1/3 x cubed plus 2 times something x to the 5 over 2. I need to undo the 5 over 2 with the reciprocal, which is 2/5. And now at the end I've got plus 1/2 of x squared plus c. That gives me 1/3 x cubed plus 4/5 x to the 5 over 2 plus 1/2 of x squared plus c. Okay, and the last question we've got at achieved level is a trapezium rule question. Now I've chucked in the trapezium rule from the formula sheet. Simpson's rule is in there as well. Just make sure that you can use both of them. So what we're doing here is we're going to use these values. So we're going to use the y values, and we also have to figure out what the width of each group is. So the width of each interval here is h, and h is equal to 0.25. So all we have to do here is to say that my area is roughly 1/2 times 0.25, and then I want my two endpoints in there once, 0.8 plus 2.4, plus two lots of 1.1 plus 1.5 plus 1.9 plus 2.2 plus 2.1. And when you chuck all of that into your calculator, you get 1/8, or 0.125, times, what does it work out to be? I think it was 20 point something. I'll just check notes for a second. Yeah, so all of this works out to be 20.8, giving me a final answer of 2.6. So there you go. I'll be back pretty soon getting through the merit questions and 2 of the excellence questions I did at the end of last year. I've just got 1 left to finish off today. Thanks for watching.